Okay, here are the answers for the 112 review preview. So for problem number 1, we have Junior is saving money in his piggy bank. He starts with 10 cents and adds 2 pennies each day. Create an XY table and a graph for the function for which X represents the number of days since Junior started saving money and Y represents the total money he saved. So at 0 days, he has 10 cents. At 1 day, he has 12 cents. 2 days, 14. 3 days, 16. It's going to keep going up like that. So I'm going to count by 2s on my graph. 4, 6, 8, 10 is where my first point's going to go. And then 12 and 14. It's going to keep just going up straight like that. Next problem says use a zero product property and factoring when necessary to solve for x. If you need to help, Google zero product property. The zero product property states that any two numbers multiplied together, if one of them is 0, the answer will be 0. So in these problems, we know that we just set each individual parenthesis equal to 0. So for example, in A, I can say x plus 13 equals 0, and so does x minus 7. So x is negative 13 and positive 7. So in B, I can say I know that x equals negative 3 over 2 and x equals positive 7 over 3. C, x is going to equal 0, or x will equal positive 3, because 3 minus 3 is 0. D, I have to do a little bit of factoring, so I can actually just make a table. So x squared and negative 5x. So we get x and x minus 5. So I have x times x minus 5 equals 0. So I know that x is either 0 or 5. E, I have to factor it, so I can box and diamond it. So I know I'm going to have negative 35x squared on top, negative 2x on the bottom. I know that 7 times 5 is 35, and I can get 2 from that. So I know I have negative 7x and 5x. So I have x squared, negative 7x, 5x, negative 35. So when I box that out, I get x, negative 7, and I get 5. So I get x minus 7, x plus 5 equals 0. So x is either 7 or negative 5. The last one, I'm going to do the same thing. So I'm going to diamond, box. So in my box, I have 3x squared, negative 5. In my diamond, I'm going to have negative 15x squared. And I'm going to have 14x. I know that if I multiply 15 and 1, I get 15, and 15 minus 1 is 14. So if I have 15x and negative x, that'll be my answer. So I'm going to have 15x, negative x. So I have 3x and x, 5, so 3x plus 5, and then negative 1. So then I get 3x minus 1 and x plus 5 equals my 0. So I know that x is going to equal 1/3 or negative 5. The next set of problems, the next problem is a factor machine. It says Terry's project for the math fair was a magnificent box that she called a function machine. If you put 3 into her machine, the output would be 8. If you put in 10, the output would be 29. If you put in 20, it would be 59. What would her machine do to the input of 5? What about negative 1? What about x? Making an input-output table may help. So if you look at her input-output table, you know that 3 is 8, 10 is 29, and 20 is 59. So you know we're doing something with adding 30 or 3, so somewhere along the ways. So I figured out the equation first because it helped me a little bit more. So I figured out y is equal to 3x minus 1. So if you do x times 3 minus 1, so 3 times 3 is 9, minus 1 will give you 8. 10 times 3 is 30, minus 1 is 29. So if we were to plug in 5, so if we plugged in x is equal to 5, y would equal 15 minus 1, 14. If we were to plug in negative 1, y would equal negative 4. Okay. Nafisa graphed a line with a slope of 5 and a y-intercept of 0, 2. So it said find the equation for her line. So I used the point slope formula. So I did y plus 2 equals 5 times x minus 0, because it's y minus, so it would be y plus 2. So then I get y equals 5x minus 2, because y would equal 2. So equals 5x minus 2. Make that y a little better. Okay. Then it says find the value of x when y is 0. So we would do 5x minus 2 equals 0. So we get 5x equals 2, or x equals 2/5. So then in each of the following equations, what is y when x equals 2, when x equals 0? Where would the graph of each equation cross the... Well, we're missing part of this problem, so we're just going to do the first two parts. So when x equals 2 in the first one, so we would do y equals 3 times 2 plus 15, so it would be 21. Then when it's 0, y equals 3 times 0 plus 15, which is 15. So same thing in the next one. So we're going to plug in 2. So y equals 3 minus 3 times 2, or 3 minus 6. So y equals negative 3. And when it equals 0, so y equals 3 minus 3 times 0, so y would equal 3. So negative 3 and 3 are the answers to that second one. Alright, problem number 17. Carmichael made a function machine. The inner workings of the machine are visible in the diagram. What will the output be in each of the following cases? So all you're doing is replacing x with the number. So if 3 is x, in this first one, it's 3 squared plus 2 times 3 plus 1. So we get 9 plus 6 plus 1, or 16. If we drop in negative 4, we get negative 4 squared plus 2 times negative 4 plus 1. So we get 16 minus 8 plus 1, or 9. And when we plug it in the last one, I'm not going to work the whole thing out, but we get 478.384, and it's actually repeating 384, but I'd give you credit if you had rounded it to 0.39, 0.38. The next problem says, does the temperature outside depend on the time of day, or does the time of day depend on the temperature outside? This may seem like a silly question, but to sketch a graph that represents this relationship, you first need to decide which axes will represent which quantity. When you graph an equation such as y equals 3x minus 5, which variable, the x or the y, depends on the other? Which is not dependent? That is, which is independent? Explain. So when you do that, y depends on x. X, because you're plugging x in and finding y. So then it says, which variable is dependent, temperature or time of day, which variable is independent? So the dependent variable is actually going to be the temperature, because we're going to look for the time of day to find the temperature. So the independent variable is going to be the time. So if we were to sketch a graph of this, we would put the time down here, the temp off to the side, and I made my graph kind of look something like this, where the temperature is going kind of up and down. You could have made it a little straighter, but usually there's ups and downs in the temperature throughout the day. The next problem says, Jill needs to cut a piece off of a 30-foot length of lumber. Create multiple representations, an XY table, graph, and equation for the function X values that are lengths of the piece Jill cuts off and Y values that are the lengths of the piece that's left over. Which representation best portrays the situation? Y, explain. So, similar to the first problem that we did, 0 would be 30, because that's how much she's going to have before she cuts anything off. So if she cuts off 2, she now has 28. If she cuts off, say, 5, she now has 25. So if we went up by, say, I think I went up by 5s, 5, 10, 15, 20, 30. So approximately right there, a little bit less, would be where we would start. And then as we kept going down, it's getting less. So we kind of have some there. So our graph is going to kind of look like that. And it's actually going to stop. So like if we were talking about domain and range, it's going to have a shorter domain and range then, because eventually we're going to run out of wood. So our equation is y equals 30 minus whatever x is. And the best representation, I would say, is going to be the graph, because the graph clearly is going to show us where it can start and stop. The equation implies that we can have negative numbers, and so does the table. So you want to make sure that you realize that we can't have more than 30, we can't have less than 30. Okay. Make a table of the graph for the function of f of x is 1/2 x squared. Describe all the possible inputs and outputs of the values. So we can start with like 0, 0, because we know that's going to be our vertex. We know our parabola is going to go up. So next I would probably plug in 2, because I know that it's going to work out well. So 2 to the second power is 4. Half of 4 is 2. So it's going to be about there. Then let's plug in negative 2. It's also going to be positive 2, because negative 2 times negative 2 is positive 4, times 1/2 is 2. So I can tell that my vertex's graph is going to go like this. So then it says describe the inputs and outputs. It's really talking about its domain and range. So the inputs can be all numbers. But the outputs have to be x is greater than or equal to 0, because even when we plug in a negative number, it's never going to go below 0 for our outputs. This problem, there was part of it missing on your homework paper, so you want to make sure that you know that f of x was negative 2/3 x plus 3, and g of x was 2x squared minus 5. So we're going to just plug in for the first one. So we're going to do negative 2/3 times 3 plus 3. So we get negative 2 plus 3, which is 1. In B, we're solving when it's equal to negative 5. So we have negative 2/3 x plus 3 equals negative 5. So if we subtract 3 from both sides, we're going to get negative 2/3 x equals negative 8 times the inverse. These cancel, and I get x equals 12. In C, we're calculating g of negative 3 in the second function. So we're going to do 2 negative 3 to the second power minus 5. So I get 9, 18 minus 5, or 13. In D, we're solving when g of x equals negative 7. So we have 2x squared minus 5 equals negative 7. So we get 2x squared equals negative 2. X squared equals negative 1. Then we have to square root both sides. Since I can't take the square root of a negative number, x is actually undefined. Okay, and E I'm solving when it is g of x equals 8. So I get 2x squared